And so now looking at example 4a, we're going to go ahead and identify what is our P, our Q, and we have another coordinate. So we know that this guy is P, this guy is Q. So we can go ahead and place those values in. And when we do that, we have y equals a times x minus. Now P here, notice how it is -9. And so that's why P itself is -9. So they actually have two different negatives. Times x minus, our Q value here is -2. Again, because Q is negative, we have a separate negative there. One's from the formula, the other guy just happens to be negative. And then we're going to go ahead and just clean this up a little bit with the signs. We have y equals a times x plus 9, because the opposite of a negative is a positive. And then likewise here, so x plus 2. And now we're at this part where we're like, okay, great. We've plugged in P, we've plugged in Q. Now what? Well, this is where our other coordinate is going to come in handy. And so we know that we have this other point, -4, 20, which represents an x and a y. And so as a result, what we can go ahead and do is plug those values in to our intercept form. And so when we do that, we have 20 equals, we currently don't know what a is, so we're going to leave it as a, but we do know what the x value is. Again, that's -4 that we're dumping in. Plus 9, and then for the other one, -4 plus 2. And so now we can go ahead and clean these up even further. So we end up with 20 equals sum A times -4 plus 9 is 5, and -4 plus 2 is -2. Next, we can go ahead and multiply those values together. So we get 20 equals -10a. And then to solve for a, we're just going to divide this -10 over. So boom, boom. Looks like a comes out to be equal to -2. So then the final part is we just put our items together in intercept form. So we end up then with, it's kind of stem just from that one, y equals -2 times x plus 9 times x plus 2. Go ahead, feel free to pause the video if you have any questions at all. Now that you guys have seen that one, what I'd love for you to do is to please pause the video and try example 4b. So again, this is going to represent our P. This is going to represent our Q for the intercepts. For our intercept form, we have y equals a times x minus P times x minus Q for our intercept form. And then we can go ahead and plug in our values. End up then with y equals a times x minus P is -2. And then x minus Q is 3. Cleaning it up, we end up with y equals a times x plus 2 times x minus 3. Our other point comes in handy now. We have this x comma y that we can go ahead and replace that in there to our intercept form. So we have -6 equals a times x, oops, no longer x, we got 1 there. 1 plus 2, and then our 1 minus 3. Again, -6 equals a times 1 plus 2 is 3 times -2. That's -6. -6 equals -6a. Then to solve for a, we would divide both sides by the -6. It looks like a comes out to be 1. So really, we're using our coordinates just to kind of help us out to find a. And again, we end up with y y equals 1 times x plus 2 times x minus 3. Go ahead, feel free to pause the video if you have any questions at all. All right, next we're going to go ahead and look at example 5. Now, this one is very similar. Go ahead, feel free to pause the video if you have any questions and give it a shot. All right, now for this guy, there's actually 2 subtle differences. You're not necessarily given a graph, which is fine, because we are given our intercepts, our x-intercepts. And so we're going to say this guy's P, this guy Q. Again, it doesn't really matter which one's which. And then we do have our x, y coordinate. Okay, so that's one of the differences, is we don't necessarily have the graph. And on example 5, we're asked to write it in standard form. So we'll have to first get it into intercept form and then convert to standard form. Pretty common question where they do ask you to convert from one form to the other. So let's go ahead, and as always, we're going to jot down our intercept form equation: y equals a parentheses x minus p times x minus q. And then we go ahead and place in our values. So we have y equals sum a times x minus -5 times x plus, or I'm sorry, x minus 4. And some students, they do ask me, hey, Mr. B, I know my x, y, can I plug that in? You can. There is some hesitancy in my voice, because if you start playing with too many numbers all at once, it might throw off a value. Like you might accidentally put a value in the incorrect place. So that's usually why I kind of break it up like this. And sometimes you're actually even given the a value. That's kind of a rare event. But like if you have, for example, vertex form, and then you know the x-intercepts are given, then you may not necessarily have to find the a value. So there are subtleties depending on the questions and even previous questions that can actually dictate that. So that's why I kind of just have students really break it up like you've been seeing here. Now we do have to find the a value on this one. So we're going to go ahead and place in our x and our y. So instead of y, we've got a -9 there, equals sum a times 1 plus 5 times 1 minus 4. And now we go ahead and clean this up. So we have -9 equals a times 6 times -3. So -9 equals -18a. And then we go ahead and divide this -18 on both sides. So it looks like a comes out to be equal to 1/2. Now we'll go ahead and rewrite our equation, just like we've been doing in the past. So we have y equals 1/2 times x plus 5, and then x minus 4. Okay, so now this is an intercept form, but they ask us to put it into standard form. And so what we're going to do is we're going to hold off on the a value for the moment, but we are going to go ahead and distribute these binomials together. So x times x would give us x squared. X times -4 would be -4x. 5 times x would be positive 5x. And then 5 times -4 would be -20. We'll go ahead and clean this guy up. So we end up with y equals 1/2 times x squared plus 1x minus 20. And then we're going to distribute this 1/2 to everything. So we have y equals 1/2 x squared plus 1/2 x, and then minus 10. This is our standard form right here. Go ahead and feel free to pause the video if you have any questions at all on example 5. All right. For example 6, we're asked to write a quadratic function in standard form where the graph has the vertex of -3, 4, and it passes through this other coordinate. So for vertex form, we're going to start off with vertex form simply because we know the vertex. Vertex form takes y equals a times x minus h, quantity squared, plus k. And so here's our h and here's our k. And so when we go ahead and place those values in, we end up with y equals a times x minus h here is -3 squared, and then k is +4. Now, when we clean this up, we end up with y equals a times x plus 3, quantity squared, plus 4. And so far, this actually should resonate with what we've talked about in the past. And the reason for that is, remember how we would always take the opposite of this value? And then this guy, we would take it just as it is. And lo and behold, that is what that is what's happening. So that's how we get that -3, +4 there for that vertex. But again, that's been a while, so we'll just want to do a quick refresh there. Okay, so now we have kind of in vertex form, but we don't know what A is, right? Well, it's following super similar to how we've been seeing with intercept form. We do know an X and a Y. And so we'll go ahead and plug those values in. So our Y value was 16 equals some A that we don't know, but X is 3 plus 3 squared plus 4. Now we can go ahead and solve for A. So we end up with A times 6 squared plus 4. So 16 equals A times 36 plus 4. So 16 equals, I'm just going to move that into the front. And then we're going to just copy it. So 16 equals 36A plus 4. So now let's go ahead and solve for A. So we would subtract 4 from both sides. Get 36A equals 12. And then divide. Boom, boom. Looks like A is 1/3. So then we know what A is. We'll go ahead and replace that into our vertex form. Y equals 1/3 times x plus 3, quantity squared, plus 4. And now, just like the last one, we want to convert this into standard form. So in order to do that, we're going to go ahead and rewrite this. Keep in mind, a binomial squared is the same as that binomial times itself. And now what we need to do is expand this out. So x times x would be x squared. X times 3 would be 3x. That would be another 3x. And then that would be 9. We can bring together some values. So we end up with x squared plus 6x plus 9 plus 4. And now we're going to go ahead and distribute. So we end up with y equals 1/3 x squared plus 2x plus 3 plus 4. And then lastly, we just bring these guys together. So we end up with y equals 1/3 x squared plus 2x plus 7. And there it is in standard form. So recapping that one, we had vertex form at first. It is first solve for A then. And then once we had the vertex form, we had to expand it out and then write it in standard form. Go ahead and feel free to pause the video if you have any questions at all on example 6. All right, looking at example 7, we have to use the table to write the quadratic function in vertex form and then rewrite the function in standard form. So just looking at example 7a, what I'd love for you guys to do is to pause the video, give that a fair shot, and then see what you can come up with, and then we'll come back together and see how we did. All right, now looking at A, there's actually a variety of ways that you can solve this one. So, you can kind of take the main path that we've been doing so far. I think, from my experience, students get generally pretty solid with that. So, what I'd love to do is actually kind of think outside the box a little bit and just kind of give you another option because it can be actually sometimes a little bit faster. So, but really you can only do this when you kind of have a table of values and even some of the key values that are there. So this doesn't work every time, but it's when you can, it's really, really fantastic. All right. So what we're going to do is we're going to start off super similar to how we've been doing this a moment ago. And so what we're going to notice is right here, notice how the one above that, the y value is the same, and the one below that, I'm sorry, above and below are the exact same y value. What that's telling us then is because this is following a consistent pattern here with the x's, that value in the middle is actually our vertex. And so what we can do is we can use vertex form then to kind of help us out here. So we have y equals a times x minus h quantity squared plus k. And we know the vertex. This is our h value. This is our k. And so we're going to go ahead and place that value in. So we end up with y equals sum a times x minus -2 squared plus -3. Now cleaning this up, we end up with y equals a times x, opposite of a negative is really a positive. And then plus -3 would just be -3. Okay, so now, just like before, we're going to go ahead and try and solve for a. Now with this, you can have pretty much any point to be able to use. So really, sky's the limit. You can use 0, 13. It doesn't really matter. Just for the sake of maybe some different numbers, I'm just going to go with like -3, 1, just to kind of illustrate that you can do this with anything. So here we have 1 equals sum a that we don't know times -3 plus 2 squared and then -3. So we end up with 1 equals a times, this would be a value of -1 squared. -1 squared would be +1. So I'm just going to then move that 1 in front of the a. And then we still have our -3. And now we're going to solve for a. So we would add the 3 over. We have 1a equals 4. And then we would divide both sides by 1. So looks like a comes out to be 4. But now we can put this in vertex form. And so you would end up with y equals 4 times x plus 2, quantity squared -3. And then you could expand that out and go like how we've been doing. Kind of a faster way though, because we're given some key values here, is notice this one's a huge one. 0, 13. So if I go ahead and construct my quadratic here, I know that for standard form it's y equals ax squared plus bx plus c. Well, I actually already have my c value. C is 13. So y equals positive 13 there. I know that. And a moment ago, I actually just found the a value. Now, the a value with vertex form is the same a value for standard form. So those will become the same thing. And so now really the only thing I need left is the b value. Well, fortunately, we actually have a lot of things to be able to help us find the b value, namely the vertex and our a. And so our vertex, again, is -2, -3, right? Now, a standard form, to find the vertex in standard form, recall it's x equals opposite of b over 2 times a. Well, we know the x value. Boom, there's your x. We also know a. Boom, it's 4. So we can dump these items in and end up with -2 equals, we don't know what b is, but it's 2 times 4 on the bottom. And then we can very quickly find b. And so we end up with -2 equals -b over 8. And then, clear fractions, because we don't like those at all. Multiply both sides by 8. -b equals -16. Divide by -1 on both sides. B is 16. So I just want you to think, like, there are other ways on doing that rather than just expanding like you were seeing earlier. So here we found b, and there's our standard form. Especially when you have the c value given where it's the y-intercept and you just found a, really then you only need to find the b value. Go ahead and feel free to pause the video. Again, though, if you did this and you decided to expand it out, totally fine too. That absolutely works. It's just, I would say, a few more steps though. So again, go ahead and feel free to pause the video if you have any questions at all. All right. Now that you've seen that little trick, go ahead and we notice, oh, yep, that's kind of, we have a vertex, we have the c value. Go ahead, you can absolutely apply it to b. So go ahead, feel free to pause the video and give it a shot. All right, so as we look at this one, we notice that this is our vertex. And this is going to be our y-intercept. And so going ahead with vertex form, we end up with y equals a times x minus h quantity squared plus k. And here's our h, here's our k. We know that essentially for the h value, we just take the opposite of that. So since it says -2 there, it would actually be +2. And then the k value, we just take it just as it is. So -7. Now we do have other values to choose from. So we'll go ahead and choose, we'll go with -3 and -12. So there's x and there's y. So -12 equals sum a times -3 plus 2 squared minus 7. So -12 equals sum a times -1 squared minus 7. -1 squared comes out to be just normal 1, a minus 7. Adding the 7 over, we end up with 1a equals -5. So a is -5. So if we had to do vertex form, it would be y equals -5 times x plus 2 squared, and then -7. For our y-intercept, boom, there's your c value. So we end up with y equals ax squared plus bx plus c for our standard form. And we know our a and our c values. So a is -5 x squared coming from the a value from the vertex form. And then plus bx. And then c we know is -27. And now really just our goal is to find the b value. And to do that, we're going to go ahead and use our vertex. Specifically, really just the x value is what you need. So recall x equals opposite of b over 2 times a. And our x value here is -2 equals the opposite of b over 2 times a is -5. Cleaning this up a little bit, we end up with -2 equals -b over -10. Multiply both sides by -10. We end up with -b equals 20. So then b just comes out to be -20. And boom, now we just fill that in. So y equals -5x squared minus 20x minus 27. So that is what you should have gotten as well. Go ahead, feel free to pause the video if you have any questions at all on example 5. I'm sorry, example 7b. Here we are at example 8. A real-world application, a house painter standing on a ladder drops a paintbrush, which falls to the ground. The paintbrush's height above the ground in feet is given by the function of the form, there it is, our vertex form, where t is the time in seconds after the paintbrush was dropped, and we're to use the graph to essentially create the function here. Well, looking at the graph, we do notice that our vertex and our y-intercept actually happen to be the same thing. This is the highest point that it will ever reach. So that is your vertex still, even though it's also your y-intercept. So that is an xy, or more specifically an h comma k. And then we also do have this other coordinate. Just to kind of keep it clear, I'm going to mention that this one is xy instead. All right. So now we have f of t equals sum a. And right now we're just going to dump in the h and the k. So we have t minus, our h here is 0 squared. And then our k value, we take that just as it is. So positive 25. Now, just cleaning this up a little bit, we end up with f of t equals sum a times t minus 0 is just t. And then we end up with really t squared. So t squared plus 25. And this should look familiar. We've seen objects dropping in the past. And so this is where it goes from, the x squared term down to the constant. And there's really not a b value given. That would be your object just dropping, just straight dropping. Now, we still do need to find the a, just like normal. And so that's where our other point comes in handy. We see that at 1 second, it is 9 feet above the ground. So we're going to go ahead and place that in there. So for future classes, I'm going to just really show what this means at 1 second. Make sure it was at 1. Yep, at 1 second, what's happening to the function? So 1 squared plus 25. And at 1 second, so f of 1 is 9 feet in the air. So we can replace that with a 9. And just to kind of do one step at a time, I'm going to rewrite that right side. Now 1 squared comes out to be 1. So 1a plus 25. And now we go ahead and we solve for a. So here we're going to subtract 25. End up with 1a equals negative, that would be negative 16. And then when you divide both sides by 1, a comes out to be negative 16. We've actually seen this a constant in the past. All right. So now, putting it all together, our quadratic model would be f of t, we do want it in that function notation, equals negative 16 t squared, we're going to kind of take it from this one, t squared plus 25. And here is our quadratic model. Go ahead, feel free to pause the video if you have any questions at all on example 8.